Welcome to another episode of Empower Apps. I'm your host, Leo Dion. Today, we are joined by Daniel Steinberg. Hey, Daniel, it's good to see you again.
Hi, thanks for having me.
Great job emceeing in Spain and hearing your talk at iOS DevCamp DC. I really loved it, talking about presentation and code and getting your material out there to the public and not being too worried about it. It was an awesome talk.
Thank you. It's one of those things that I think throughout my career, I've drawn inspiration from other fields. And so I look at what actors do and people doing vlogs and authors, and we can learn so much from other people.
Yeah, and I believe that was the talk where you had a lot of cooking analogies, which I thought was super relevant because that was around the time of Thanksgiving. And it reminds me of another book I've read by Amy Hoy called JFS. The F stands for a certain word that I can't repeat. But she talks about just like when you're building something, how it's okay to use pre-built components. And like how if you're building a Thanksgiving dinner, you don't need to make everything absolutely from scratch. I think you use that analogy as well.
Yeah, I think I started by talking about, I'm sitting here trying to present something or write a book, and the first thing I think of is, hey, I'll write my own presentation software. And then we go nuts. We spend all our time doing the thing that isn't the thing we want to ship.
Yes. I think that's really hard for those of us who are software developers to try to make sure we don't get lost in the weeds of rebuilding stuff and optimizing stuff rather than just, using what's already existing out there and going with it.
If you're a book author, you particularly know that there's all these things trying to keep you from actually writing. We can edit and make this paragraph better. And so what's a better thing to do than to delay it and write code,
Or pick the right font, right? That's the other thing. If you're not a
Sure.
developer, people just go on forever picking the right font.
Sure.
So, yeah, fantastic talk. And I'll post a link to the show notes for others as well to take a look at.
Thank you.
So today we are talking about a kind of a topic I've touched upon a few times with everybody from Jason to Majid when we talked about SwiftUI, or Donnie talking about Combine. And we'll deep dive into why it's important in Combine too. But this idea of functional programming, I think it's kind of a foreign concept to a lot of people because something like object-oriented programming is something we all learn as software developers in school. But they don't really teach, at least when I went to study computer science, they never really get into functional programming. But it's gotten really, really important over the last few years. Could you maybe explain what is functional programming, first of all, and why it's so important?
It's so funny to me that you preface it that way because I'm old enough that I remember when it was really important that we start explaining what object-oriented programming was. And that was a hard sell that people thought, this is not a natural way of thinking of it. So one of the things I really enjoy about teaching functional programming is people like you tell me, but objects are the natural way to think of it. That's the way I was taught. And it is these cycles. And, I've said before, when you look back many, many years, functional programming's been around a long time. The concepts have been around in mathematics for 100 years and in programming for, 60 years or more. When you look at Lisp was created, in 58?
You're right.
And so these aren't new ideas, and Backus was writing in the 60s. So a lot of these are new ideas to me, to you, but not to the community at large. And so I'm fairly new to this. I've only been looking at these concepts for a few years. And I was lucky to have some great people to follow who sort of pushed me along and gave me great resources.
Yeah, and I think it's interesting talking about how it's been around for a while. It almost seems, at least in the Apple sphere, I think, even though we've had things like Reactive Cocoa, which used Objective-C, it's become a lot more easy to implement in the Swift world because of the agility of Swift. And I think maybe that's brought it for a lot of developers in the space.
I'd say two things in Swift have helped a lot. One is that closures are so much easier to write than blocks were in Objective-C.
Yeah, or selectors.
We still have selectors, but so the syntax is so friendly, and it's easy to pass around functions, and it's easy to store functions as properties. And so that's really nice. And the second thing is Swift's emphasis on value types. And because we have value types, even though a function, a closure is a reference type, the focus on value types makes us focus on functions that take something and give you back something that has been changed rather than mutating the thing itself.
Yeah, mutating is the key word there, yeah.
So those two things, I think, have made Swift very friendly to this notion of functional programming, even if technically Swift is not a functional language.
What's great about Swift is that you can apply a lot of different patterns. When you're using, you could do functional, you could do object-oriented, you could do, the big one that Apple talks about is protocol-oriented programming. You could still use delegates and things like that. All sorts of patterns can be applied in Swift, and that's kind of what's been really helpful for a lot of folks.
And I'm glad you mentioned that, because to me, one of the things that we're just learning now is what are the appropriate patterns for Swift? Don't keep taking the Gang of Four pattern and apply them to every language. What are the patterns that make our lives easier?
Yeah. Hey everyone, I want to let you know about Audible. Audible is a leading provider of spoken word entertainment and audiobooks, ranging from bestsellers to celebrity memoirs, news, business, and self-development. Every month, members get 1 credit to pick any title plus 2 Audible originals from a monthly selection, and access to daily news digests from the New York Times, Wall Street Journal, and the Washington Post, as well as guided meditation programs. I want to let you know about a few books that I've been reading or have been listening to using Audible. One book I want to recommend is Talking to Strangers, What We Should Know About the People We Don't Know by Malcolm Gladwell. As somebody who runs his own business, it's always helpful to understand and be able to interpret how people react or how people act in certain situations. And Talking to Strangers is a great book by Malcolm Gladwell. This book really investigates how we misinterpret people in all sorts of situations, everything from Bernie Madoff to Amanda Knox to some of the situations in the news lately, African Americans. And I think I highly, highly recommend this book, and I highly recommend it through Audible, because not only is it a reading of the book, but Malcolm has his own podcast company, and he understands the importance of having audio within the book of these actual situations that he talks about, as well as like hearing about different court cases and court transcripts being brought to life, military psychologists, scientists, criminologists, etc. The real people, the real interviews of the real people, the audio of those interviews are in the Audible book. So I highly recommend it. And if you are interested, you can go to www.audibletrial.com/empowerapps, and you will get 2 free audiobooks free. Just go again to the link in the show notes, audibletrial.com/empowerapps, to get your free 2 audiobooks. Thank you again for listening to the program, and thank you, Audible, for supporting our show. The problem I always find with the Gang of Four patterns is people look at it and they're like, I'm going to go in and I'm going to adopt an adapter. It's like, or I'm going to adopt a builder. And I think it's much more as you program, these patterns grow out of the architecture that you build. And then it becomes more, oh yeah, I can see what I'm doing here. This is a builder. Or I can see what I'm doing here. This is an adapter. I think that's one thing I try to tell like novices is like, don't just go into it and be like, I'm going to use this pattern here and specifically apply it. It's more like these patterns are the natural progression of a good architecture.
Well, I'd say 2 things to that. First, the patterns in the Gang of Four, there's nothing wrong with them. They're just not always what we need in functional programming.
Right.
And number
exactly.
2, the approach I've always loved is Josh Kirievsky's approach, which is refactoring to patterns. You look at the code you have and say, if I applied a state here, if I applied a visitor here, my code would be clearer. So you don't set out to build a template pattern, but you notice that a template pattern would really help here. And so he talks about refactoring in the direction of that pattern.
Yeah, I like that a lot. That makes a lot more sense. The other thing with a lot of these patterns is they're kind of different layers. I find that like just because you do functional programming doesn't mean that you're not using object-oriented. A lot of people feel like object-oriented is like, don't apply that pattern. But I think it's much more that a lot of these other patterns that have come out, a lot of patterns are kind of like layers in your software, in your code. And you can apply multiple varieties or multiple combinations of patterns within your code. And it's not just necessarily that these patterns are, how do I put it, like against each other, so to speak.
Well, you can see this in practice as we adopt SwiftUI and Combine. that we need to find new ways because the data is flowing differently and the views are being assembled differently.
Right, that's true. You can't do MVVM and do MVC. That doesn't make sense.
I don't make that distinction. To me, MVVM is just another take on MVC. It's just you've split up your controllers in different ways.
Oh, interesting. I never thought of it that way. So you see the controller as being something like the view model, I guess.
Just like in our software where we break up things in different ways and we use different language, I don't fuss over what we're calling it today. It's still a controller that's talking to other controllers. If it's the controller talking to the view, okay. I used to have little controllers that would talk to the network or to the data store. So I guess you can sell more books if you create a new acronym and sell your pattern.
Yeah, that's true. So if you're going to teach somebody functional programming, I like the idea of mathematics as a way to do that, because that makes a lot more sense in its relationship and terminology when it comes to functions. But to like a typical novice programmer who's learning functional programming, what would be your first type or function that would help somebody understand this concept?
So in mathematics, a function takes a value and returns something else. A function doesn't mutate that value in any way. And so thinking in terms of that and stressing that, moving away from the side effects, not that side effects can never be used, but we should be aware when we're using them. I remember when I first came to programming and people said, well, you're a mathematician, this should be natural. And the first line of code that I read was x equals x plus 1. And I thought, that's nuts. How could x equal x plus 1? And so once you realize that equal signs means is replaced by, it changes your perspective. So you can't just look at code with a mathematician's perspective. Now, mathematics is being used in code in many ways. You see category theorists coming in and talking about functors and monads and things like that. That's a whole different mathematician. So we think of mathematicians, perhaps if you're not one, in very specific ways, but mathematics is all over programming right now.
Yeah. So what would be some functions that we typically use when we're doing functional programming? Like, for instance, map, I think, is an easy one for people to get, is when you take an array and you call map in order to create a new set of values. That's one example that comes to the top of my head. What are some other ones that you can think of?
So if you're using functions from arrays, then there's that whole family of functions in arrays. When you do sorted, you're taking an array and returning an array that has been sorted. You aren't modifying the original array. You do that with sort. When you do filter. So all of these functions on array have this interesting property that they accept another function. They're this higher order function. That's a level of thinking that we actually use sorted and we use filter without thinking what we're passing it is a function. And once you get your head around these higher order functions, these functions that accept other functions or return other functions, I think you've taken that next step.
So some common types where you might apply functional programming, such as an array, would be like an optional or a result or a promise or future of some type. Those are some common places where I've used functional programming to transform values.
And the nice thing is, that's exactly what a mathematician or a programmer does. We step back and we look for these bigger patterns. And we notice that the way you treat an optional and the way you treat an array and the way you treat a result type, they have these commonalities. And in fact, there is a map for all of these types. And there's a map for combine. And so these commonalities that say, if I know how to adjust a single element, then I can adjust that single element inside of an array, inside of an optional, inside of a result type. It's the same thing that we're doing. We're just doing it in different settings.
So one of my favorite functional methods or functions that I've used a lot is on two arrays, actually, is zip. That one is really powerful when it comes to being able to take two arrays and combine them together and then being able to do some sort of transform on those values. Another one that I think a lot of people get confused by, and I'll let you tackle this one.
Zip is a great one. And in fact, the version of zip that you're talking about is often called zip with or map to. And the idea is I have these two arrays and I'm going to combine them and I'm going to do something to the things in. So it's sort of like a zip followed by a map in a way.
Right. That's actually true. Yeah.
The zip gives you the tuples and then, or tuples, depending on how you were raised. And then the map does something with them. So that is very powerful. And that's something that we use all the time in Combine, we have these two different streams of values coming in, and we either use zip or combine with depending on how we want to group those things that come in.
Right. And then the other one I wanted to mention, and that was a big change for a lot of folks a few years ago, was distinction of flat map and compact map. And I specifically want to deep dive into flat map, especially when we get into Combine, about what flat map actually means. Do you want to tackle this one?
Sure, but it's unfortunate that compact map was misnamed for so long in the Swift community because that's the one that people knew. That was the handy one. It allowed you to take a function that mapped from something to an optional, throw out the nils, and unwrap the things that were optionals but not nil. That's not a flat map. And so the fact that it was misnamed confused people for many years, and I think made it harder for people to get their heads around flat map.
Yeah, I agree with that. So like the cases that I've used flat map and for what it really means is when you want to avoid, and I wrote a whole blog post about this, but essentially you want to avoid situation where you have some sort of generic type. And I don't know how to phrase this, but you double the generic. And what flat map essentially does is it flattens it. So for instance, if you have an optional and you want to, I'll have this case where I have a string that I need to convert over to a different type by parsing it. And in some cases, it can't be parsed, so it'll return an optional. But let's say I already have an optional string and I convert that. You end up with the situation where you have like the double question mark optional, which is not what you want. You want just a single question mark optional. And flat map typically will take care of that by flattening the value, flattening the optional into a single type. Another one is like a result where you...
Well, let me jump in on your optional. In the case of optionals, we use flat map when our function is from, say, a string to an optional int. And now I give it an optional string, and I don't want an optional int. That's what you're talking about.
Right, the double generic. I don't know how else to call it.
What's cool about flat map isn't just that you're unwrapping it one level, which is what a lot of people focus on, because a lot of people learn it in the context of array. What's cool about it in the case of optional is, in a map, I have a function, say, from string to int. And when I apply it to an optional string, nils map to nil, and non-nils map to whatever you get when you apply that function. Mm-hmm. But with flat map, nils map to nil, and because you're applying a function that takes a string and gives you an optional int, you can also end up with a nil from your actual value.
Right, exactly.
What flat map does that map doesn't is it takes into account your current context. And so map, you're lifted up into that world and you just apply the function. In flat map, so let me say that differently. With map, I can use the same function from string to int and map it into the world of arrays or optionals or result or whatever. In flat map, my function must know about the world it's entering because it must be a function from string to optional int or string to an array of ints or string. It must be a function into that world. So in a way, flat map already has knowledge of the world that it's working with.
Right. And that's passed down to the other generic types. So like, for instance, with a result, you'd use flat map if you have a function that returns a result. And that way you don't end up with, like I said, result, which is not what you want. I've been doing a lot of stuff with Swift Neo.
It's partly that with the double nesting, but it's also part of that with I'm carrying along knowledge. And so if you imagine I hit a URL, I extract data, I get the JSON, I transform the JSON into a type. At any point, something could go wrong. And so it's nice to be able to take those errors and deal with them appropriately. And I can't do that without having something like flat map, which says, don't worry about this till later. It's kind of like optional chaining is for optionals.
Right. Yep. You got it. I've been actually doing a lot of Swift Neo, and that's another place where I use flat map quite a bit with their event loop futures, because I'll have to make like 2 URL calls and I need to flatten it in some way. And that goes back to what you were saying about making sure that you carry that over within its context and not lose that.
So I see a lot of that in Combine where people have gotten the idea that flat map is a way of getting out of if I end up with a publisher of a publisher. Usually, if you're flat mapping just to remove one layer, you're flat mapping too late. You should have done it in the previous step when you're doing the map that caused that thing to be double wrapped. So one of the greatest examples I've seen of flat map in Combine, for example, comes from when they introduced Combine in the videos last year's WWDC. So that would be 2019. They have an example of an error. And so they put that catching of the error inside of a flat map so that you can just continue nicely instead of the first time you encounter an error stopping. And so if people want to go back and look at that talk, it was a really nice example of using flat map and Combine.
Yeah, and I'll post a link to that video in the show notes as well. So yeah, that's kind of the big elephant in the room with functional programming has been the introduction of Combine last year with SwiftUI. I'm a big fan of Combine, and it's been really powerful. And its main component is this concept of the publisher. Maybe you can explain how the publisher works in the context of functional programming.
Well, one of the nicest things that Apple did with Combine is they did it in the context of things we're familiar with. And so if you look at result type has a success or a failure. And a lot of the functions that work with result type and a lot of the concepts we have in our head around result type are the same in publisher. Publishers have an output and they have a failure type, an error type. And so result maps over pretty nicely to that. So if you're not dealing with asynchronous code and you get your head around result type, you're in good shape to understand a publisher and the operators that transform these publishers.
What are some gotchas or issues you've run into, especially in Combine, when it comes to implementing functional programming that people kind of make a common mistake of?
So a couple things. First is one of the people that I look to for inspiration is Chris Eidoff, who, as we were all coming to functional programming, he was coming to OO in a way. So he'd come from Haskell to Objective-C to Swift, and we're coming the other way. And so we're being precious about never using mutating methods. And he's saying, no, they're okay. You can use them in certain situations. And so part of that is you start this new methodology and you read the books and you get very religious about it. And you think, there's only one way to do it, and I've got to be so pure about it. And you realize that there's these gradations that you don't have to give up everything you're doing. You can still be an OO coder. So I look at languages like Clojure, which on the JVM mix functional and OO. We have the same in Swift. There's no reason that we have to give up these things that we love. We're just adding new tools to them. And we are becoming more careful as we start paying attention to these guidance.
Yeah, I think that's really true. It's interesting to think about mutating because I'm always uncertain about that. So it's good to hear Chris's guidance on that. Hey folks, I wanted to talk to you again about AppFigures. You probably already know them about their analytics and their App Store optimization. AppFigures really is about giving app makers the tools they need to get more downloads and revenue. Well, now AppFigures can help you track competitors, from how many downloads they're getting and how much money they're making, to their audience demographics and which SDKs they use. Their competitor intelligence really gives you great context. Say a competitor adds like a new feature or was mentioned in the news recently. With AppFigures, you can see if that brought in more downloads right away. Got a great idea for an app or a game? Well, with AppFigures, you can figure out how big that market is and how much money you could be making with it. And that's just scratching the surface. Whether you're growing your app or building a new one, AppFigures has the tools you need that will reduce the risk, but also get you more downloads. You don't need a large budget or a data science degree to do this kind of thing. AppFigures has made it affordable and simple. On top of tools, AppFigures also provides a lot of great guides and tutorials to take you step by step through gaining more visibility with ASO and increasing your revenue by learning from your competitors. They just released a free guide on that, actually. So go ahead, head to the link in the show notes and try AppFigures for free. If you like it, use our special code EMPOWER3030 to get 30% off for the next 3 months. Thank you, AppFigures, for sponsoring our show. What do you think are some other benefits when it comes to functional programming that folks won't be aware of when they get into Combine?
So what people in functional programming, what people that practice these things say is your code is easier to reason about. And it sort of goes back to Jeff Raskin and the humane interface, where people talk about, this interface is natural. It's not that it's easier to reason about until your eyes get used to it. When you first look at this code, oh my gosh, it looks awful. It
Mhm,
doesn't look
mhm.
anything like what we used to do. I remember the first time I saw a session on reactive, I thought, this is the dumbest thing in the world. And now it feels natural to me. Reactive didn't change. My eyes got used to seeing what I was seeing. And I wonder how you unsee that enough that you can explain it to other people. So that's what I'm wrestling with now. I'm starting to write my Combine book, and I'm trying to write it so that people don't roll their eyes and say, that's just stupid.
Mhm, mhm. Right. Yeah. One of my bad habits I think I've run into with functional programming is keeping it organized and not just keep chaining functions on top of functions on top of functions. How do you keep your code organized in a healthy fashion when it comes to functional programming?
So you can do it in pieces in the same way we do it in OO, where if a method gets too long, and too long is a matter of taste.
Mhm.
Some people like very short, some people like, but when a method gets too long, we split it up. And usually the guidance is you split it into pieces that you can name. We can do
Okay.
the same thing with our chains. We don't have to have one monolithic chain, and we don't have to use custom operators that you have to learn. Oh, that's what that symbol means in your code base. You can use things that I can read, I can reason about, and I can test the individual pieces. So one of I talked about the great things from Apple's introductory sessions to Combine, and they were really masterful. But one of the drawbacks was all of their examples lived on a single slide. And so in my Combine, I'll take a workflow and I'll split it into pieces. And now this is the piece that takes it from the initial publisher and transforms it in some way. And now the next piece splits it so that two people can subscribe to it. And that I won't do everything in one place. I'll split it into pieces, which makes it more modular and makes it more reusable. The same thing is true in functional program. The same thing is true in OO.
Right.
You
Yeah.
know, OO and functional, when you go back and you look at early Smalltalk, you look at early Lisp, they're actually doing the same thing. They just were using a different metaphor for how they split the code.
And that goes to my other question, which was going to be about like, how do you implement functional programming in such a way to be able to do unit tests? And I talked about this actually at 360 iDev about how I've created this concept of like a publisher factory. And what do I actually call it? A publicist, because I'm a dork. But in any case, I created these like unit tests that will test to see if the mapping works out correctly. If I input a certain value, I get a certain value back out, which I expect based on that, the way that data is mapped or those publishers are mapped accordingly.
If I've done my job right and I have one of those functions that we described before that takes input and doesn't mutate, it just gives you output, that's very easy to test.
Right.
You can put input into that function all day long and test that the output is what you want. And now you start chaining those together, you can test those combinations as well.
Right.
And so if you're doing functional programming where you're not doing the mutation, testing becomes very easy.
Yeah. And then in some cases, you want to test, like you said, those combinations and those relationships and make sure they work out correctly.
But then taking two functions and composing them is also a function that takes an input and gives you an output, also very easy to test.
Yep. Exactly. So I know you already have a functional programming book. How has that helped you in your journey writing this new Combine book that you're having out soon, I guess?
I love that you ask it as a journey, because when I write a book, that's exactly how I think of it. It's a journey I'm taking the reader on, and I'm just the guy over their shoulder talking to them, but they're the person that has to slay the dragons. And so the functional programming book I wrote because when I was learning functional programming, there were these words people would use. Often, I used to be a book editor, and I also used to edit magazine articles. And it was the same thing in both of them, that I would read these articles these authors had written, and they were great, except the first 6 paragraphs had to go. After that, they were great. So the author had to write those 6 paragraphs to get them into it, but they don't help the reader in any way. They're the theory. So almost every book you read about Combine starts by saying, here's what a publisher is, here's the publisher protocol, and so on. I think back to the days when I used to teach calculus. And I don't know, did you ever take calculus?
Yeah. Yes.
So when you take calculus, it's usually taught, we teach you what limits are, and then we teach you the definition of continuous. It's the limit from the left equals the limit from the right. And then we teach you the definition of derivative, and you're doing it as a limit. And then we teach you this shortcut that's trivial. And you go, why did I learn all that stupid stuff? But when I used to teach calculus, I did it in the opposite order because at least a third of my students had taken calculus before. And so I taught them the quick way to do it. And then I taught them the theory because now I have their attention and they know I'm not hiding the easy way to compute it. I'm teaching the theory because now they know how to solve the problems. But by understanding limits and continuity, you understand there's some functions that you can't take the derivative of. So I try to do that in my books too. Instead of starting and going in that order, I have the luxury because I don't have to tell you the truth from the beginning. I can tell you half-truths, get you working and get you doing it. And now I can drop back and say, now let's open it up and see how it works. So that's kind of the way I write my books.
That's really interesting. I love that analogy with calculus because I think like that's one of the hard things when you're communicating a concept is you want to get into the weeds of things and just like explain how it works at the micro level when you don't actually need to, especially for a novice.
Now, I say that, and yet in my SwiftUI book, which I wrote a year ago, I already was doing property wrappers and what are now called result builders, what were then called function builders. So we did get into the weeds. But first, I showed them how to press a button and have something show up on the screen.
Yeah, so that way they can actually see what their end result is going to look like. I think that's really important. Before we close out, I wanted to talk about something you just mentioned to me earlier, or something I've heard you say, especially since you're really good at writing books and things like that. Something you've said about all folks nowadays, not just developers, but this idea that we all write for a living. What exactly do you mean by that?
So of all the skills you have, think of how much of your time you spend communicating by writing. You write an email, you write on the Slack channel, you write a commit message, you write code. We're communicating with each other. And so people go and learn a new programming language, they learn a new methodology, they learn SwiftUI and Combine. But really spending time thinking about your writing and taking time before you send that email you send to 10 people, and you just dash off and you reply all, if you really take time on it and think about what is the subject message, what is the first paragraph, maybe there doesn't need to be a second paragraph. Spending time on writing can help your career in dramatic ways. And that's what I mean is we all write for a living, and we don't seem to take writing as seriously as we should.
That's really interesting you're talking about that because I had Paul Hudson on back in February, I'd say. And we talked about what are some things that folks should be doing for their career. And one of the things he said is writing and communication is such a big deal.
That doesn't surprise me at all. Paul is a magnificent writer and writes every day.
Yeah.
And so he exercises that muscle, and he's also got an ear to how what he says comes across. And so he's a great example of someone who writes well and knows that he writes for a living.
Yeah. And you don't have to be Paul to like write prolifically. Like you could be writing emails, Slack messages. You could be writing code that you will share with other people that you need folks to understand. Like you said, Paul is top notch when it comes to that stuff. But I think we all could benefit in our careers or as a community by just continuing to work that muscle, like you called it.
And remember, Paul wasn't always Paul, right? He became this way. And so the Paul that we know, who's a beautiful writer and successful and prolific, there was a time before he was that person. We can all become better at what we do.
So if somebody, let's say, wanted to get into more writing when it comes to content in the Swift space, what do you recommend as a good way to practice and hone your craft?
So one of the biggest things that I mentioned before about writing is everything inside of you wants to not do it. There's something that's saying, oh, there's something I should read. There's something I should look at. Oh my gosh, do I smell pancakes in the other room? And so everything
you forgot,
wants...
You forgot the one where you want to write your own blog engine in Swift. That's the other one too. That's a distraction.
Right. So the thing that I would say is make a schedule and write. So early in the pandemic, I was encouraged to write a weekly newsletter. And so each week, each Tuesday, I sit down and whatever's on my mind, I write for an hour, and then I send that out along with links to things that I found interesting during the week. The fact that I'm on a schedule means that 30-some weeks later, I've written 30-some posts. And so put yourself on some sort of a I'm going to do this every week. John Sundell said he wrote an article a week for so long. Now he's coming to the end of that, but that's what got him on this road. So deciding you're going to share something once a week encourages you to find something to share. And so you'll spend the weekend before you're writing investigating things that you want to write about, writing little code snippets, exploring, finding something worthwhile. And it's amazing what your mind does when you sort of know that there's this regular task. It's, again, like going back to mathematics, going to bed and waking up with the proof to a theorem I've been thinking about for a while and thinking, I couldn't crack it when I was awake. How'd I come up with it when I was asleep?
I love that. Have you heard the book Atomic Habits by James Clear? Yeah, I mean, that's one thing he talks about, starting off with little things that you do every so often to practice that muscle. And it sounds a lot like what you're talking about.
There's a famous story of a mathematician who in a dream was visited by another mathematician who gave them the answer to something he was struggling with. And when he woke up, he didn't know if he should credit the mathematician because it was only his dream of them.
Nice. Well, as I put together my plan for 2021, I'll definitely take that habit idea when it comes to writing to heart, because that's definitely something I want to continue honing that skill next year. So that's really helpful.
Now, I don't want to pretend that I'm successful at this. I've been planning to launch a video series for 4 years, and I haven't done it, and I've experimented in the space. And I was planning to write this Combine book for 6 months. I've now sent the first chapter to reviewers. Now it feels real. My goal for next year is to actually launch this video series that I've been talking about doing for forever.
What do you think has helped you? Help isn't the right word, but I'm going to use it anyways. What has helped you procrastinate doing this video?
I think it's overwhelming. I think it goes back to what you said about I started to build a presentation tool for it. I'm afraid of getting caught up in doing something and will someone care about it? And I think that's important to say out loud, that even though I've done so many things and people have been so nice to me, I still have those doubts. Will this video that I produce every week be something that anybody's interested in? So we all have those feelings. So
have you thought about just doing like a 5-minute video and just putting it out every week and see,
so
like
I've been
doing micro pieces of that, I guess.
I've been doing that this year. I've been posting free videos online, and I've also been trying to do my conference talks as videos so I can post those. But what people like in the contract with someone who's receiving pre-content and the contract with someone who says, yeah, that's willing to pay. That's something I'm willing to pay so much a month for. That's very different.
Oh, absolutely. Yeah. Yep. Yeah. Anything else you want to cover before we close out?
As much as I love these conference videos that we're doing and we're distributing, I really miss going places and meeting people in person. I mean, that's why I've agreed to start doing podcasting, is getting to talk to other people in the communities, something I really miss.
Yeah, I agree completely. I hope that happens sooner than later, but we'll see. Because there's something about just meeting someone in person and sitting down and talking to them as opposed to just pulling up Zoom or Skype or something like that. Well, thank you so much, Daniel, for coming on the show. I really appreciate you taking the time to appear and talk about this really important subject.
It was my pleasure. Thanks.
Where can people find you online?
Pretty much everything I do is tied to Dim Sum Thinking, so dimsumthinking.com or at Dim Sum Thinking on Twitter. And then my publishing site is Editor's Cut, but of course I link to that from my other site. And I'd love to have you subscribe to the newsletter. I tend to be really bad at selling my stuff. And so instead of selling my stuff, it's just a weekly essay and pointers to other people's stuff.
Awesome. And I'll provide links to that in the show notes as well. Folks can find me on Twitter at Leo G. Dion. My company is Bright Digit. You can find that at brightdigit.com. We have articles at least twice a month that you can check out. I have one coming out very soon, probably by the time I release this, on error handling in Swift. So you'll definitely want to check that out. Thank you so much for listening. And if you could, please post a review in Apple Podcasts, Google, or Spotify. Thank you again, and we look forward to talking to you again.